Welcome to This Explainer, everyone. I am absolutely thrilled you're joining me today because we are going to unlock the secret to something literally every aquarist chases: true, unwavering reef tank stability. If you've ever felt like keeping your tank balanced is just this constant, frustrating tightrope walk, you are exactly in the right place. Today, we're diving into the foundational element that can absolutely make or break your entire system.
So let me ask you, is invisible evaporation silently stressing out your corals? It's really easy to just look at a dropping water line and think of it as a minor nuisance, right? Just another chore you got to check off your list. But we really need to reframe that completely. That dropping water line isn't just an empty space in your glass. It is an active, invisible threat that is quietly altering the chemistry of your tank minute by minute, hour by hour.
Which brings us to Section 1, the hidden evaporation threat.
To really grasp why this matters, we kind of have to look at the mechanics of evaporation itself. Think about it. When water evaporates, literally only the pure water leaves the tank and goes up into the atmosphere. The salt stays completely behind. This is the absolute core chemical truth we have to deal with here. Because only the water evaporates, the salt that's left in your tank becomes increasingly concentrated. If you lose a gallon of water to evaporation, you haven't lost a single grain of salt. Your tank's salinity is spiking, and honestly, it's going to keep spiking until you intervene. Now, you might be sitting there thinking, well, hey, my tank is pretty stable. But think about the everyday evaporation drivers we all have going on. Things like sump airflow, fans blowing across the water, high-intensity lighting just baking the surface, hot rooms, aggressive surface agitation for gas trans change, heavy ventilation, the whole shebang. Evaporation happens so much faster than most people realize. A tank that seems perfectly balanced on Tuesday can start experiencing some serious drift by Thursday, especially if you've got a fan running or a highly agitated sump.
And that leads us right into Section 2, protecting coral health.
Let's get right to the heart of the matter with this quote. Reef tanks live and die by stability. That perfectly nails the incredibly high stakes of reef keeping, doesn't it? A lot of marine organisms, particularly your sensitive corals and certain invertebrates, they just do not tolerate rapid or repeated changes in their environment. In the ocean, salinity is incredibly vast and completely stable. When you force these creatures to endure daily swings in a glass box, you are basically fighting their biology.
So what does this stress actually look like in practice? Well, if your salinity is swinging back and forth, your corals are absolutely going to tell you. You'll see things like slowed growth, retracted polyps, and just this overall irritability during feeding or routine maintenance. By holding your salinity steady, you are drastically reducing that environmental stress that forces your corals to close up and stop growing.
But here's the kicker. The damage isn't just physical, it's chemical too. Fluctuating salinity directly undermines your foundational chemistry. You see, salinity isn't just one parameter among a bunch of others. It is the baseline. It's the foundation. When your salinity is constantly shifting around because of evaporation, it becomes incredibly difficult to balance other crucial elements like alkalinity, calcium, and overall nutrients. You are essentially trying to build a house on a shifting foundation. Keep that salinity locked in, though, and balancing everything else gets tremendously easier.
Okay, so how do we fix it? That brings us to Section 3, ending the parameter swings.
Before we get into the ultimate solution here, let's talk about how most people try to fix this manually, and really, why it just falls short. Manual top-offs, sure, they're effective in theory, but they absolutely depend on you being perfectly consistent. And let's face it, we're human, right? Busy work weeks happen. Vacations happen. Simply forgetting for a single day happens all the time. And when you slip up, those evaporation-related losses just accumulate. That leads to wildly fluctuating density readings and totally unstable refractometer measurements, which basically turns your routine testing into a giant guessing game.
So let's look at a better way in Section 4, how ATO systems work.
The crucial point here is this. An auto top-off, or ATO, is basically a system that monitors your tank's water level and automatically adds fresh water to replace exactly what evaporates. Because it's only replacing that lost water with fresh water, it automatically counteracts that evaporation drift we talked about earlier. No more constant manual corrections. And this creates an incredibly efficient automated loop. Step 1, the sensor is continuously monitoring your tank's water level. Step 2, the exact moment it detects a drop from evaporation, it triggers the system. And Step 3, it automatically pumps in just the right amount of fresh water. This simple, repeating loop frees up your time so you can actually enjoy your tank. Instead of lugging around heavy jugs of water on some strict calendar, you can actually focus on observing coral behavior, dialing in your flow, and testing your foundational chemistry.
All right, moving on to Section 5, choosing safely and smartly. Of course, anytime you introduce automation to a giant glass box full of water sitting right there in your living room, you gotta be smart about it. Because if an ATO malfunctions and pumps your entire freshwater reservoir into your tank all at once, your salinity is going to crash and your reef will be in massive danger. To prevent this, you absolutely must prioritize specific features. You need a system that's specifically designed for reef use. It's got to have highly reliable sensors and a tightly controlled pump, but most importantly, it needs a fail-safe float or a cutoff mechanism. Redundancy is your best friend here, folks. You want a system designed so that if one sensor fails, a backup mechanism immediately steps in to prevent a runaway freshwater addition.
But remember, automation isn't magic, right? Even the absolute best equipment out there needs some sensible oversight to act as that truly quiet stabilizer we want. So, step 1, you still need to test read your sensor behavior to make sure it's actually triggering when it's supposed to. Step 2, regularly verify that the pump output is clear and flowing properly. And step 3, periodically confirm your salinity manually with your refractometer just to ensure the machine is doing its job. Trust, but verify.
Which leaves us with one final, pretty vital question to think about. Is your manual top-off routine secretly harming your reef? Literally every time you forget, every single time you let that water line drop just an extra inch because you're swamped with life, you are rolling the dice with your coral's health and your tank's chemistry. An auto top-off system isn't just a luxury, it's a foundational tool for creating that unwavering stability a thriving reef absolutely demands. I highly encourage you to take a hard look at your current routine, evaluate your parameters, and consider if it might just be time to let automation take the wheel. Thanks so much for joining me for this explainer, and I will see you on the next one.